JHU APL has partnered with the financial sector to pilot the IACD framework with the goal of improving cybersecurity through information sharing and automation. The integrated pilot effort consists of an automated representation of the FS ISAC feed as a publisher and 3 financial institutions as subscribers. Subscribers utilize the feed to take automated response actions in their enterprises. The following workflow involves the process of automating a response against an indicator of compromise, or IOC. This workflow takes action when a malicious URL IOC is received. The IOC is ingested by Phantom Orchestrator, and enrichment is performed using VirusTotal to collect additional information on the URL. After obtaining the enrichment data, the URL is detonated in a sandbox to see if any malicious behaviors occur when visiting the URL, and the results are recorded. A whois lookup is performed on the domain to collect metadata, such as country of origin and registration date. Once all enrichment and metadata information has been obtained, an automated response action is taken, and the URL is blocked in the Palo Alto firewall. In the firewall, we see that IACDautomate.org has been added to the URL block list. When we try to visit the IACD homepage, we receive a message that the site is blocked. After blocking the URL, the enrichment data and results from blocking the URL are forwarded to Splunk. In Splunk, we're able to see the enrichment data, as well as the status of whether the automated response was successful. This workflow uses several playbooks which provide enrichment, notification, and actions to a SOC operator and enable the operator to take actions using human-in-the-loop processes. The workflow starts when a domain indicator of compromise, or IOC, is received from the FS ISAC via a STIX-compatible client. It is ingested into Phantom Cyber Orchestrator and contains the indicator type and indicator value. This indicator is then passed to the domain enrichment playbook, which provides 3 important functions. First, it queries and formats any external enrichment. Second, it queries the SIEM for occurrences of DNS lookups for the IOC in question. Finally, the playbook generates a ticket in the ticketing system for this occurrence. The identifier for the ticket is stored in Phantom for later reference. Once the enrichment playbook has completed, a ticket is created in the ticketing system. In this example, custom fields were added to provide the content of the enrichment information. The SOC analyst can examine the enrichment information and then use the ticketing system interface to choose appropriate actions. For this example, the analyst chooses both to block the IOC at the DNS server, as well as create a ticket for a NOC specialist to remediate the workstation. Once the ticket is saved, the requested actions can be read by Phantom during the next workflow. Phantom Orchestrator needs to poll the ticketing system to find tickets and parse the actions that were selected by the SOC analyst. This polling workflow is timer-driven. When executed, the tickets are parsed and a reference table in the ticketing system is accessed to translate the data in the ticketing system to action names. The actions are stored in Phantom for the related IOC of each ticket. A call is made to the appropriate playbook for blocking or NOC ticketing for each ticket action combination. This short playbook receives the IOC information through Phantom and the SOC ticket ID from the ticketing system. At this point, all the actions have already been ingested by Phantom, so we can clear the to-do list of actions in the ticket. The playbook then adds the domain to the DNS block list and updates the SOC ticket with the result. The other available action in this workflow is to generate a ticket for the NOC to remediate affected endpoints. As with the blocking playbook, the SOC ticket to-do list is cleared. The host information is retrieved and formatted from the SIEM search in the enrichment workflow, and a ticket is created with this information for the NOC. Additionally, the SOC ticket is updated to notify of the NOC ticket creation and provides a link to that ticket. As the actions are completed by Phantom, the ticketing system receives the updates. We can see the ticket for the NOC is created. It contains the host, user, and timestamp information. If we open the SOC ticket, we can see the associated updates for the NOC ticket creation and blocking. The SOC operator can now choose to close this ticket. The following demonstration shows workflow error handling by providing feedback to analysts when errors occur. When applying automation, it is important to have visibility into the process, especially when errors manifest. Often, specific error information is lost for the overall success or failure of the workflow. In order to provide a more granular view on error handling, ServiceNow is used to supplement workflow auditing. The workflow is triggered by an IP address, IOC, from the FS ISAC feed. After the IP IOC arrives, an analyst is prompted to choose an action to take. The analyst can choose to block the IP, unblock the IP, or do nothing at all. Once this is complete, the subsequent actions of the workflow are executed automatically. The workflow sends a request to block or unblock the IP at a specific Palo Alto firewall, then requests to commit to the firewall rules set. If successful, ServiceNow creates a ticket documenting the actions taken. The Palo Alto action can fail due to misconfiguration or service interruption. When this occurs, the workflow utilizes ServiceNow to create a ticket that provides contextual information about the failure. This provides analysts with a centralized knowledge base about automated response actions. The information provided can be used to remedy the misconfigured firewall or take manual action to block the IOC. In the event that ServiceNow is also unreachable, the workflow will notify the analyst through the Phantom dashboard. This allows the analyst to create a ticket in ServiceNow manually. When adopting security automation and orchestration capabilities, it is critical to have visibility into the integrity of the services used for automation. The following Orchestrator Monitor workflow demonstrates the ability to ensure orchestration capabilities through periodic application connectivity checks via a heartbeat workflow and alerts on Orchestrator component failures. To perform this monitoring, there are two types of information we will be gathering: Orchestrator logs and a heartbeat. The Orchestrator logs and the heartbeat will be aggregated in Splunk. Three types of alerts are created with this information: a lack of heartbeat alert, an alert on application connectivity errors in the heartbeat message, and an alert on a configurable quantity of errors in Orchestrator components found in the forwarded logs. The heartbeat is created using a playbook in Phantom. Within this playbook, several GET or query-style actions are run against the various configured apps in the Phantom instance. In this case, we are checking connectivity with Exchange Web Services, EWS, Splunk, ServiceNow, and VirusTotal. The results of queries and GET requests are then formatted and placed in a JSON object to be sent to a Splunk instance. In order to run this playbook like a heartbeat, the Phantom Timer app is used and set to trigger every 5 minutes. To determine whether these messages are being received, a saved search alert is created in Splunk. This search checks if a heartbeat is not received within the 5-minute span as configured in the Timer app. If no heartbeat messages are found, the saved search runs an action to create an incident in ServiceNow via the REST API. Another saved search monitors the success, failures of the applications as described in the heartbeat message. If specific applications have failures, an incident is again created in ServiceNow. A final saved search monitors the errors found in the logs of the orchestrator, specifically checking for a quantity of errors in the decide-D log of Phantom. Phantom's decide-daemon log contains various errors generated from the execution of playbooks, making this an important log to monitor to ensure orchestrator health. This saved search will create an incident for investigation in ServiceNow via the REST API. A threshold over a time span will be looked for in the saved search.